Stuff we're supposed to know right now. So if I have like 3 to the x equals 7, how would I solve this?
Log base 3 7
Right.
equals x.
Log base 3 of 7 would give me the x. Okay, so if it starts in exponential form, the variable's in the exponent. You can use log, change it to log form, and then this will solve it for you. Okay, and then if it's the other way around, like, if it's like, well, log base 5 of 2x equals 7 or whatever, how would we solve this one? 5 to the 7th equals 2x, right? So we'd have to figure out what 5 to the 7th is and then divide by 2. Now we get, okay, that's the old stuff. Also some other old stuff that we're going to need today. It's kind of a review today. I mean, there's kind of some new stuff, but it mixes a lot of the old stuff. Log of a plus log of, this is the worksheet from Monday. How can we simplify this? Right, if the logs are added together, then these, you can put it as 1, and then these two things are going to be multiplied together. So it's log of a times b. And then if they're subtracted, what? A divided by b. And if there is an exponent, what can we do with that exponent? It can move it to the front. Or if it's in the front, sometimes we need to move it there. So that would be the same as b times log of a. Okay. Got all that in your brains? Blink, 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 blink. Okay. There is, okay. I forgot where.
She likes side eyes. She's like, keeps going.
She adds so much.
Okay. Do you guys remember? I need to back up a little bit. You guys remember the exponential growth formula? Or is it T, yeah. So the starting amount, the percent growth, like 3%, 0.03, the time, right? Okay, that's just basic exponential growth or decay. And then what if we want to do compound interest? How does that change it? R over K to the KT, where K stands for the number of times you would get paid in a year. Like if it's monthly, K would be 12. Daily, 365. All right. So compound interest means you don't get paid at the end of the year. You get paid every whatever day or month. So there's something called continuous compound interest, which means you get paid constantly. This is kind of a weird concept. But even though you're getting paid interest constantly, it actually, your money doesn't go up to infinity. Because as you get paid more and more and more often, you're getting paid less and less and less and less for each payment. So they kind of cancel each other out. And anyway, so they came up with this concept. So if you get continuous compound interest, this kind of, this parentheses in here kind of just simplifies to something that they call E. E is a value that is kind of like pi. It's an infinite decimal. And this is a button on your calculator also. If you want to figure out E, what E is, you can use your calculator, but it's kind of weird because there's not just an E button on the calculator, there's like an E to the what power on your calculator. So if we want to figure out what E was worth, what could we plug in? E to the 1. So actually, let's go ahead and do this. Everybody on your calculator, the E should be close to the logs, probably above a button called LN. Everybody plug in E to the 1, see what pops out. Yeah. Just like pi, we usually round it to the second decimal place, so it's about 2.72. Oh boy. Okay. And yeah, so I can't remember how they simplify all this into this, but this is the formula for continuous compound interest. It's actually a simpler formula, ironically. So this is where the E came from, though. Like, you might be wondering, why are we using E? If you have continuous compound interest, and it doesn't necessarily just have to be money, but a lot of times it is. Okay. Oh, that reminds me. So instead of them just having log with a base of E, I guess this thing was common enough that they decided to make it its own special thing. So they call it the natural log. So instead of log base of E, they just write it as ln. And that stands for natural log. Don't ask me why it's backwards. Maybe they got it from another language or something. So if I have log base 5, okay, that's base 5. What if I just put log, what's the base? So there's an invisible 10. And if I have natural log, that means invisible E. Okay. I think we're set. I think we're good to go. All right, number 1. Let's try this one without a calculator. So, what's my invisible base right here? E. So this really means E to the, remember it's like the ACD thing? Like E to the what power equals 1. Yes, E to the what power equals 1. And the answer is 0. Because anything to the 0 power equals 1. Okay, now on number 3, it's just a messy decimal. So just like yesterday, they want you to round to the 10,000th place, which means what? 4th decimal place. Number 2 comes out nice because it's like E to the what equals E. What would number 2 be? E to the what equals E? 1. So you could plug that into your calculator, but you'd have to put a little 1 exponent right there because they don't let you just plug in E.
Wait, I have a question.
Yeah.
No.
Okay, so since those first few are calculator, I'm going to jump to number 6. Okay, these, they do want you to do it without a calculator. They requested, and it's pretty easy. Okay, so what's my invisible base? E. So this means E to the what power equals E to the 7th. E to the what power equals E to the 7th. That would be 7. E to the 7th power equals E to the 7th, right? So that would be the answer, 7. So on number 7, natural log E to the negative 2. So this means E to the what power would equal E to the negative 2. Negative 2. 8, a little bit tricky. The other class figured it out. What do you guys think on 8? Right. The third root of E squared is the same thing as E to the 2/3. So the 2/3 would be the thing with the thing. All right, number 9. Okay, write each expression in a single natural logarithm. So we are not solving this. We're not plugging this in the calculator. They want us to kind of simplify this into just a natural log. So in other words, they don't want the 4 right there. So where else can we put that 4? Exponent. So unlike the worksheet, let's go ahead and simplify that. What is 3 to the 4th? It's 81. Yeah. So this is kind of like the simplified version, natural log of 81. They don't want you to put it in the calculator. No decimals on these. Number 11. I'm gonna write this one down. Plus. Okay, so they want us to combine all these into one natural log. Okay, what can we do with this 2? Put it on the exponent, so that's gone now. And then when we're adding logs, what can we do with these numbers? When we add logs together, we're multiplying those numbers. So what's x squared times x squared times x to the 4th? What is x squared times x squared? 8. X to the 8. Remember when you do x squared times x squared, you're adding the exponents, right? So this would just be natural log of x to the 8. Alright, 13, they wanted us to solve these using natural logs, but it would just make the problem much harder. So we're just going to solve these normally like we did on the last assignment. So, how did we solve this on the last assignment? Log base 6. It goes boom, 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 like left right now. So log base 6 of 7 gives us. The directions, they changed it up on us just to throw us off, I guess. It says nearest thousandth on 12 through 19. So what's the thousandth place? Third decimal. So they want the third decimal on this one. Alright, same thing on 15. So Willow, how would that one set up?
Log 7 16 equals -4x.
Yeah, so remember log base 7 of 16. This is just some weird decimal number. Okay, so this is just one number, but how are we going to have to finish this to solve for x? Divide by -4. So whatever that decimal is, divide by -4, and that'll do it. Hey. Okay. Man. So this is kind of, we did this on the last assignment too. This is, we're starting with a log, and we want to kind of, transform it back into exponential form. But right now, we need to clean this up a little bit. Now, if we just have what we want is something, I don't know, like this, like a basic log function. Log base this of this equal that. So we can just turn it into exponential form. This has something extra, a 5. So we kind of need to clean this up and get rid of that 5. So how do I get rid of that 5? Divide. Because it's on the front, it's multiplied, so you can get get rid of it by dividing. Oh, what's wrong with me? Another class wore me out, I guess. Alright. No, it was just the lesson was kind of rough. It was not kind of easy like this one.
Like a moderately easy.
A little bit easy.
No, like a tad bit easy.
Okay. Okay. Alright, now that we've kind of cleaned up the log, now it's kind of ready to transform into exponential form. So what would this be in exponential form? What's my invisible base right here? E. So it's e to the 0.32 equals 7x. Okay, e to the 0.32, this is just some weird number, some weird decimal. But to finish it off, how do I solve for x? Divide by 7, yeah. Who's the sub over there?
Where's the range?
Oh, no, not a sub. Oh,
No, it's a sub.
the brother.
His dad.
Dad, okay.
Father. Much angrier father.
Yes, very angry. Yes. No, it's Sydney. Yeah.
Oh, you're free to abuse Forrest.
Bro, you need to stop.
Walking stick or whatever.
You suck.
Oh, she might fall over and break. Sorry.
I think you need to leave.
All right. Number 19. Sorry,
You're not sorry.
are you still gonna give me a card with money for my birthday?
Nope.
That's what my grandma does.
Oh.
I'm sorry,
No, I hate
I got a problem.
I hate everything here. Especially this one. Where am I there because you exist? And you're ugly.
She passes her pain on to you. All right. Can I clean this up any, do you think? Or is it just ready to go?
Totally ready.
Are you?
It is actually ready. This is all, it's just log of this stuff equals that. We can't really clean it up. This is all inside the log, so I can't just like -1 or anything. So it's ready to transform into exponential form. What is this going to be? E,
One. Oh, E. 1.
e to the 1.
Try to
Equals
use this back
X
button.
Okay, so e to the 1, remember, is like 2.72 or whatever. But to solve for x, we're just going to have to minus that 1. But it did say 3 decimal places, so you can't just do 2.72 minus 1. Like 1.7.
Just gotta stick each line to the nines straight. What's this? In a deep voice.
Oh, 21, yeah. Yeah, the 21, those problems are like the bonus from yesterday. We're not going to do those. Actually, 26 and 27, I wish I would have assigned that. Those are kind of easier. Okay, 30 and 31. 31 to be specific. Okay, this is the continuous compound interest stuff. So what was the formula for that?
A or T.
A times e to the RT.
Oh, same thing.
Oh yeah, usually if they write it in function form, stuff like that. But this is where the magic happens right here. So on 31 it says Brent invested $8,000 into an account that compounded interest continually. So where's 8,000 gonna go? Right in front. Okay. E is not a variable. E is actually a number value. It's a constant, like pi. So it's just gonna be E. R and T. So it also says he's getting 10.25% interest. So what is this as a pure decimal? Right, 0.1025. We're gonna move it back a couple times. So the R is 0.1025. Okay, here's the tricky part. It doesn't say how long he invested his money. So we don't know what T is. That's what we're trying to figure out. But it says how long until he gets $11,500. So in other words, we want this formula to equal $11,500. Okay. So you guys see what kind of problem we're dealing with here? It's kind of like number 13, 15, those problems. Because we have a variable in the exponent. So we're going to turn it into a log. That's what logs are for. Okay, but we can kind of clean it up because let's get rid of this big guy. How do I get rid of 8,000? Divide. So he is gone. You could turn that into a decimal. I usually just maybe reduce it a little bit, like 115 over 80. You could do more, but it doesn't really matter. This is not the final answer. This is just something we have to plug in later. Okay, so what would this be in log form? Okay, log base e, but instead of log base e, what else could we write for that? Natural log. Okay, so there's an invisible e down there. So that's that, and then we go over here, right? So it's 115 over 80 equals 0.1025 t. Okay, remember this is just some weird decimal over here that our calculator will tell us. But how am I going to have to finish this one off? Divide. And we're talking about years here, so. Huh? What'd you get? Yeah, they just put 3.5 years. That is what they put. Okay, 30 is actually easier because they do tell you what the time is, like what T is. But there is a little bit of a trick, so I guess we'll look at it. They don't tell you years, they tell you 30 months. So that's kind of the tricky part. So Eve deposits $12,000 into a 30-month CD that compounds continuously. So where's the $12,000 go? In the front, yeah. So times E, and then the rate is 3.8%. So that's going to turn into 0.038. Okay, here's the tricky part. The time they gave us, it said it's gonna be 30 months. Yeah, so 30 months is not the same as 30 years, right? So we can't just plop a 30 right there. So how do I turn this into years? Divide by 12. Yeah, Forrest got it. He said it's 2.5 years. So we'll put a 2.5 right there for our time. Okay, and we don't need algebra on this one. We're just figuring out what that is. How much money will she have? So since it's money, you probably want to round to the 1 cent place, the second decimal place.